Okay, so this is your helpful hint video for the FRQ I assigned for homework on this Tuesday, 8/13. It's coming from FRQ from year 2004. It's question number 1D. I believe that there's going to be, I'll read it. You know, I'm assuming you guys have already read it, but basically what we have here is we're dealing with a function that represents the flow of traffic. They're telling us that F is measured in cars per minute. So it's kind of important to pay attention to units on these things. It also tells us that T is measured in minutes. The question is asking us to find the average rate of change of the traffic flow on this time interval, and we're being asked to indicate the units of measure. So there's really two things that we're being asked to do here. One is find the average rate of change, and the other one is give the units of your correct answer. Now this topic here is something we'll get to a little bit later in the year, but it's not that difficult, so I think I'm going to go ahead and give you some advice on it anyway. But this part here is mainly what we've been talking about in class today. So to do this, I think there's going to be three things that you guys will want to be given some hints for. Okay, one hint is, of course, you need help finding the average rate of change, probably. That's what we're learning right now. The second thing that you're going to probably want some help with is you're probably also going to need to have some help with figuring out, like, how do you find like sine of like a weird number like 5? What is that? What is that? And then number 3, the next thing that we're going to probably need help with is how do you get those units? We kind of hinted at something like that in class today, but I'll show you how to make it a little more explicit. But those are 3 things that I'm going to be giving you hints for. Now, I'm not going to go over the problem for you because you can go on YouTube for that. The point of this video is so that you can get some helpful hints so that you can do it on your own, and then use the video just to check your work. So first of all, let's go ahead and take a look at the first thing. Let's figure out how to find the average rate of change. Okay, so let's just say I have a function here. I'll make it a really simple one. Why don't I go ahead and just use x squared? Okay. Suppose I wanted to find the average rate of change. On the interval from, let's say, -2 to +3. Okay? Well, I just want to give you guys some knowledge. Now, you don't have to graph on this problem, okay? But I just want to give you guys some perspective about what we're doing here. First of all, notice these numbers. What kind of numbers are they? They are x values. And now this graph here, this is a parabola, right? So we know what this looks like. So when x equals -2, you know, maybe we're like right here, and when x equals 3, maybe we're like up here. And as you guys remember in class, the average rate of change is the slope of the secant line that connects those two dots. So what we need to do then is we need to take the x values that they've given us from -2 to 3. We need to find the y values that go with it. And once we know what those are, we can calculate the slope of our secant line with our good old trusty slope formula. And that's it. So let's do that. When x equals -2, what is y? Well, let's plug it in. If you plug in -2 up here for x, you would get -2 to the 2nd power, which is 4. Right? If you were to plug in 3, you would get 9. Now that we've got 2 points, I can do my slope formula. So I can do y2, which is 9, minus y1, which is 4, all over x2, which is 3, minus x1, which is -2, and I would have the following. That would be my average rate of change, which is the slope of my secant line connecting the 2 points that have -2 and 3. So The steps are find your y values by plugging it in, and then calculate your slope. Okay, that's the big idea there. That's pretty much what the main idea of what we're doing here today is. Now the next thing I want to talk about, number 2, is let's talk about the units a little bit. Okay, so let's say that let's stick with something simple here. Let's say that F represents weight, and let's say that X represents time. Okay, so that means that, let's say that our time is in seconds and our weight is in pounds, let's say, okay? So what this is here is this is -2 seconds. I know that doesn't make sense, sorry. And then 3 seconds. And over here we have 4 pounds and 9 pounds, right? So if my input is time, seconds, and my output is pounds, then these are pound values and these are second values. Now coming over here to your slope, the 9 and the 4, what were those? Those were pounds, right? So 9 pounds minus 4 pounds is 5 pounds. Now these were seconds. 3 seconds minus -2 seconds gives us 5 seconds. And so what are the final units then for the slope? It's pounds per second. So for your problem that you're working on, you're going to think about what are the units for the top, what are the units for the bottom, and you just make a fraction out of them. Okay? So that's the 2 things. So we've talked about average rate of change. We've also talked about units. Okay? The last thing that you'll probably run into that's a little bit challenging on this is at some point you're going to be plugging in a number to a function that has sign in it. So, you know, like I'll just use the function that they actually give us here. I'll do one for you. Let's take a look here at this. Suppose I wanted to plug in 10 to this function here. So I would replace t with 10. And so now I've got 82 plus 4 sine of 10 over 2 is 5. Well, I need to figure out what sine of 5 is. Okay, so what you're going to do then is you're going to get your calculator, and you're going to want to make sure that it's set to radians and not degrees. Everything we do in calculus is in radians. So everybody's calculator is a little bit different, but if you're using a TI-83 or an 84 like I recommended you guys to get, radians and degrees can be accessed by pushing the mode button. And right now I'm already on radians. That's good. So I want to figure out what sine of 5 is, so all I have to do is push sine and then 5 and then enter. And I've got my answer. It's sine of 5 is -0.959. Just so you guys know, in calculus, we always round to the 3rd number after the decimal place, the thousandths place. So since this is a 9, that bumps the 8 up to a 9, and that's going to be where we plug in there. We'll talk more about rounding in class later, but for now, that's going to suffice. And then, of course, after this, we have to finish the problem. We need to do our actual math here, so let's go ahead and calculate it. Don't actually need to write this. I'm just going to type what you see there into my calculator. So it's going to be 82 plus 4 parentheses negative. Don't get the negative and the minus sign mixed up. They are different. 959. And there's our final answer, 78. Okay, so if you plug in 10, you're going to get 78.164. Okay, and going back to our units, they told you that F, the units for F, are cars per minute. Okay, so that whatever this is, I plugged in 10, which was minutes. So at 10 minutes, the traffic flow is 78.164 cars per minute. Okay, so we talked about three things. How do you find the average rate of change? You find your y values, and then you use the slope formula. The next thing we talked about was units. You look at your slope formula, you think about what units are on the top, what units are on the bottom, and then you just put them together. And then we've also talked about how to evaluate something weird like this. Make sure your calculator's in radian and just let the calculator do the work. Okay, so those three things are the things that I think you would get hung up on there. So I'll leave it at that and let you guys go ahead and go back and continue trying to work on that on your own if you need to.